Thanks for joining us today. This is the Densify webcast on using the latest instances effectively from the big three cloud providers, AWS, Azure, and Google. So we've got an interesting 30 minutes lined up for you. And today, all the talking and the deep thinking will be done by Mikhail Kuznetsov, who's our VP of Product Strategy. My name is Andy Welton, VP of Sales. How are we doing today, Mikhail?
We're doing great, Andy. I'm excited to take us through the catalogs and all the latest changes.
Well, they say change is good. You go first. And if there's one thing that changes a lot, it is the catalogs in these instance provider or the cloud providers. So let's go through some of that stuff today. If you want to flip to the next screens here.
Absolutely.
Fact, I'll let you cross the agenda. Yeah.
So today, basically, quick intro, and just to position to start us, I'll show a little bit of how the catalogs were changing over the years for each one of the big three, and the recent growth trends, and then we'll focus and go deep on our actual topic, which is the changes and additions in the last 12 months. What's new for each of the cloud providers, but then also what are the common trends, what are we seeing them all doing, probably for a good reason, and then of course how can you, the customer or practicing partner in and around cloud technologies, capitalize on those performance gains of the latest instance generations. What are the factors that may make your modernization project a success or hold you back, and also of course talk a little bit about where Densify can help with the modernization and the general optimization in and around use of cloud, whether it's infrastructure as a services or other types of products in the cloud. We'll have some time for questions, and there's actually another webinar in 2 weeks with a somewhat related topic that you might be interested in. So let's kick it off with a viewer poll, and the poll is open. Basically, just we wanted to know a little bit. We talk about the big three, whether you're using one of those or more than one. Or you're using something else, please let us know. It'll just help me focus on the provider that you would be interested in.
So we'll take a maybe 20 seconds for folks to answer this. And again, it could be multiple choice here, at least more than one, where you may be running in Azure, but also got workloads in VMware on-prem and moving to the cloud. So we'll wait for folks to answer that, and then let's see what we get. Still collecting responses. While we wait, I just wanted to remind folks that there is a panel inside your GoToMeeting little widget there where you can ask questions during the webinar. Some of them I will attempt to interrupt Mikhail and answer them. Other ones I might just answer live online, and other ones we just might wait till the very end, depending on the question. But please submit them there, and we'll address them during this session, one way or the other. I think that's enough time. What do you think, Mikhail? What do we got?
I think that's good enough, Andy. Basically, I'm seeing an even split, AWS and Azure, and Google just a little bit behind, and then a small percentage of folks thinking about moving to the cloud while running currently on-prem. But that, of course, could be a combination. Maybe somebody is using cloud, but also thinking about migrating, say, the rest of the environment. So that helps me a lot. Thanks. So AWS and Azure equally, and then just still quite a bit of Google interest as well. So let's look at those catalogs. I'll actually start with AWS. So that's kind of an interesting, they call them the funnel charts, but that looks more like a pyramid to me. AWS started way before 2013. I just it was 2007, and they had a one instance, the M1. But up to 2013, they had 28 in their catalog. So, and that's a combination of instance, family, and size. And then over the years, as you see, they about just 9 instance types shy of 500, over 77 instance families, and they kind of listed here those instance families. Of course, the ones that you probably most easily recognize would be the M1, M5, or M6i. One of the newer ones we'll be talking about. So your general purpose instance, but they also have many others, what they call families. And as you see, some of them may or may not qualify as a full family because it's still kind of general purpose, but you might have like an M5 and with extra networking, a little bit faster CPU. So we kind of, if you identify and just look at, say, flavors and generation combinations, we'll end up with 39. It's just, again, to kind of give you an idea of the spread. If we look at Azure, Azure actually started in 2014. So, so the first kind of pyramid step here is empty. They started with a catalog of 29 instances, and just as of now, they surpassed AWS in terms of number of choices available in their IaaS catalog. Interestingly enough, exactly same 77 family count over 5 generations, and 43 flavor generation options. And as you see, they're a little bit wordier on how they name instance sizes, so I had to use a little bit smaller font to fit them all here. The GCP, they started exactly at 2013, and that's kind of an interesting shape. We see that they stayed with the 24 catalog for a number of years, and their approach to kind of machine families and generations in general is different. You will see that what they call a machine family is actually broader than what we call a flavor, because within many families, like an N1, they actually have several flavors. They have standard high CPU, high mem N1, same for N2, same for E2. So everything that's marked with a star here has that. They also offer custom machine sizes. So in addition to canned standard sizes, and when I say standard, it's not just standard, what they call standards, but high CPU, high mem, you can have something in between. Or you can even have an extended custom size and kind of pay for a lot of memory and very little CPU, but that will cost you more. So you could kind of say that with that custom flexibility, it's almost infinite number of choices. But the customers leverage it to their advantage. We typically see maybe 100 more choices utilized, say, at a large customer in terms of custom machines. Also another thing about GCP is on the generations. Rather than calling it a new generation of machine when, say, a new hardware version is released, they just tend to do a silent upgrade. Like N1 went over 6 generation of CPUs architectures. And N2 is just 2 for now, but it's counting. They might add more. So that's just shows a different approach. So let's take a look, somewhat similar data, but just kind of wanted to show it as a line chart, just growth from 2013 up. And here's where you see Azure surpassing AWS. And as you see GCP, I don't want to say trailing behind, because that's not a competition here. Because of the custom, they're quite higher, but they kind of have their own path. But what I wanted to show here, that with that fast rate of growth, we are basically seeing the number of choices go to several hundreds, and this is not that easy to manage and keep track of. So if you haven't really been, paying attention, say, to the latest trends, and that's another, say, like how many instances, say, were released in 2021, 2022, don't feel bad, because we're going to look at the last 12 months for each provider and see, what happened. So for AWS, 101 new instance types in 16 families. They started introducing what we call Gen 6. So it's M6i, C6i, R6i. So Intel has a full gamut of, call it major food groups: memory optimized, compute optimized, general purpose. And then AMD is behind, but they got M6a and C6a with AMD Milan. Intel latest gen is Ice Lake, and we'll talk a little bit more about that chip. I personally love it, great performance. In addition to kind of these major food groups, you got new memory optimized families. The X2Is of 3 different flavors. They also keep on modernizing the GPUs, so both G5 and VT1, and they actually go in a little bit wider on the Graviton, which is their ARM, they own processor chip, and they expanded. They had the M6G, C6G, for example, but they also expanded that to GPU optimized and storage optimized. Of course, for these to make any use of those, you need to have the essentially all new software, all new images, because it's just a completely different instruction set. Might not be usable to, say, standard apps that x86 code. Azure, 247 new VM types, two and a half times more than AWS. In a lot of families, you got what they call V5 instances, which is, if you don't count the promos, it's kind of Gen 5, but because they introduce promos and they're kind of in the middle, we could actually say that that's even more than Gen 5. So Intel Ice Lake, AMD Milan, and D and E families, so general purpose memory optimized, and a whole brand new flavor of instances, confidential, again in D and E, which has memory encryption and at rest encryption there. There is high performance FX family. There are memory optimized, high volume memory MV2s, and then they have the GPU optimized families as well. For GCP, and again, GCP have lower counts, 29 instance types in 2 families, but they updated 2 existing families by adding new platforms there. So you got the 2 new families introduced, a C2D with 3 flavors: high CPU, high mem standard, and T2D, what they call them Tau. Those are standard, and all of them running AMD Milan. And then they actually add in Intel Ice Lake to N2, and they modernizing N2Ds as well with the Milan.
What's remarkable really is how many instances there are and how anyone can kind of keep not only keep track of what these things mean, but how do you choose? It's like there's some new instance, maybe I should go to that. If only there was some software that could help with that. But anyhow, I'll carry on.
Thanks, Andy. Yeah. So basically, in terms of trends, latest and greatest processor platforms are being leveraged. So I probably repeated Intel Ice Lake 5 times in the previous slide. High performance instances. So AMD already had Z1, and then now in the last year we are seeing Azure adding FX, GCP introducing Tau, and actually C2D as well, kind of in that ballpark. We are seeing these higher performing instances typically come in bundled, with fast SSD disks, while your general purpose instances rarely, if ever, typically never would have ephemeral storage bundled or local storage, whatever you call it. That would be potentially an option, like a D option, that you would have to ask for separately, and that would cost a little bit more. We've seen even bigger VMs. So there's a huge VMs for kind of in-memory databases or other like SAP HANAs, or other type of uses that require these massive instances. And they existed before, but they've been modernized, of course, and they've been made even bigger. ARM-based instance types are kind of starting, but again, that's a whole new ball game because it requires very different software, very different optimization. AWS have been added for a couple of years now, and they have Graviton 3 in preview, still in preview, by the way, since the last reInvent, so still not generally available. Azure has they own another ARM chip in preview. But once again, that's something that you kind of need a whole new different software image for. Let's look at the performance gains and actually how do you use those instances effectively. I'll start basically just going to the basics a little bit and saying, well, cloud is a way to sell technology as a commodity. You have a bucket of compute. It's t-shirt sized, small, medium, large, extra large. And then the cloud vendors use very simple letters to reference very complex technology concepts. So something like an M6I in these three letters has captured the M, that's the general purpose with a particular ratio of CPU to memory 1:4. It's a generation 6, and okay, it's using Intel, and it's actually latest Intel because it's 6 and it's Ice Lake. But you might not know all that. You kind of need to read between the lines. I actually saw a similar approach of t-shirt sizing catalog in my grocery store. They sell chicken breast trays, and they all priced the same. Are we getting the same value here? It kind of looks at a first glance. This is a picture I took just from my shopping trip last week. And if we zoom in, you see that these buckets are not the same. That's weight here, it's in grams. So you have like 1.5 pounds, and you have almost like 2.5, 3 pounds in the other one. So, and just like the grocery store example, cloud instances can be priced the same and they're not the same. Specifically, M5 and M6I, they cost the same for on-demand since introduction. And unfortunately, the performance is not printed there. AWS stopped doing their own benchmarking. They talk in press release. Let's talk about the M6I. They in their press release they talk about 15% better compute, price performance, 20% higher memory bandwidth, and some advanced features like TME, total memory encryption. The real world performance testing, and I just have an example of reputable site that I kind of trust what they've done there with their research, 20 to 60%, depending on the tests we're talking about. And then if we go deeper and we say, well, yeah, but are there those advanced features, right? How much can they bring me if I enable versus disable them? You can see that the factor can go up over 4 times, leveraging some of the advanced Intel optimization capabilities to the max. That's the kind of performance boost you can expect. So, obviously things are far from trivial here, and the gains are even better than what I saw in my grocery store experience. So, which factors do you need to consider for modernization? Well, first of all, does the new instance type provide new available capabilities? What are they? Are you looking for faster performance? Is there lower latency? Is there better I/O throughput? Do we have a bigger disk? Are there some advanced hardware acceleration features, those premium features that are baked in? And then the next question you ask is, can your software make use of that new technology? And some of the premium features like AVX 512, in order to use those vector operations, which can significantly boost performance of encryption and image processing and other types of algorithms, well, they got to be enabled. You need to have the right code with the proper compiler options enabled, to just grab an image ready to go. And if you're using one of those, well, it would be a very smart idea to modernize as fast as you can. But can you? Is the instance type already available? So the press release, of course, went out, and you typically see it available in 1, 2, 3 regions. It could be East Coast US, where they start from, or the US Central, or somewhere else in the world, and then they slowly make it available elsewhere, say Europe, and places like EMEA or Brazil. They might not get it for a number of months until it actually rolls out there, because they got to get hardware on the floor. They got to get all the typical things that are associated with data centers to make it available. And then, is it reasonably priced? Are the performance gains that you get justifying maybe additional price? Because it may or may not be the same price or cheaper, but it might actually be more. And then finally, are your existing images and machines compatible just from the basic performance of having the right kernel drivers? So when we're talking about AWS, for example, a lot of things associated with Nitro hypervisor, like ENA, EBS optimizations, NVMEs, drivers, is a requirement. It's a must before you can modernize, say, to a Gen 5 from Gen 4. In Azure, we have 2 hypervisor versions, so what they call Gen 1, Gen 2 VMs. In some instances, some of the very latest ones, they only support Gen 2 VMs, and it's a fairly involved process. Essentially, rebuilding. It's a very different BIOS mode, and then also to make use of some of these features, even if they support backward compatibility, you gotta kind of enable, like there might be a reason to run a V2 even if you Gen 2 VM, even if you can't get by with Gen 1, and it would be a good idea to say flip a few switches and go to maybe premium storage sometimes to get faster throughput. So so those are the factors in a nutshell. It can be evaluated manually. Densify has criteria like that codified in what we call our compatibility rule sets, and then we also use the real world resource usage, build patterns and trends, and predictively see if maybe we can also optimize and adjust the infrastructure to the resources that are available in the cloud. And do you all have something to add?
Yeah, I think that, just to summarize, is you go through all these new options that are introduced year over year, and now, each cloud having hundreds of choices and all these additional considerations around storage and networking, and whether or not certain components of the chipset are enabled or accelerated. I think it just underlines the fact that people can't do these types of evaluations by hand anymore. Even if they could at one point, machines are going to help. And when you start looking at even getting into Kubernetes or containers, where you've got tens of thousands of components to size correctly, at some point it will be software that does all these things at some point in the future, if it's not happening already. So the great thing is we have introduced a solution. We've supported one for years that can actually help customers figure out what is the best supply that will match the demand being generated by things in the cloud. And so, if you go to the next slide, I think I want to speak to that one for just a second here. In conjunction with Intel, we've introduced a program called the Intel Cloud Optimizer, which is essentially Densify running under the covers for a program that is sponsored by Intel. And for qualifying customers, Intel will sponsor the use of our software, our core analytics software, for a full year. And during that time, there will be expert assistance received from Intel and Densify to help customers evaluate and determine, what sort of optimization opportunities they have under the covers. As all these different cloud providers introduce these new capabilities, and it is available. It works against AWS, GCP, and Azure. And so there's a little QR code, and certainly you can contact us through standard mechanisms on the web pages. I think it's Intel Optimizer at densify.com or at intel.com, or just scan that little QR code. But it's an absolutely fantastic program for customers to get in the door, and essentially no risk to determine what their opportunity is in the cloud. And maybe the next slide, Mikhail. And so yeah, we got an upcoming webinar. So just to delve a little deeper into the topics, and thank you very much for going through this content today, Mikhail. There's another webinar that you're hosting in 2 weeks. It's essentially version 2, or the deeper dive into leveraging this the catalog to the max. Maybe you want to speak a little bit more about that.
Yeah, we'll talk about the full capabilities, essentially the full gamut of choices. How do you navigate a catalog? I'll give you a few examples of navigating, say, Azure catalog, some of the complexities that are involved with that, and the benefits that you can gain. And we'll also talk about the actual operational practice of actioning out those recommendations. So even the best quality, most accurate recommendation still needs to go through the paces of actually, hitting the operational aspect of, say, cloud consoles, and what could be the gotchas and factors that need to be considered. So again, give you some examples of successful and not so much optimization projects.
Great. Well, 2 weeks, same time, same channel. So come back in 2 weeks, or just scan that code and register for that webinar. We'd be happy to take you through.
May the 4th be with you. I gotta love that date.
Right, May the 4th. If you want to flip to the next slide, and we'll just wrap up here with a minute left. If you have any questions, I see a couple in the console here, and I've been answering through. There's some resources here that you can link to. So there's case studies there on the left-hand side. I think that one is relative to containers, and we're going to talk about that in a second. There's a white paper you can download with some great information on how you get this continuous optimization in cloud and containers, and then our social links down below. So 2 quick questions I'm going to throw at you here, Mikhail. So quickly.
Sure.
You've talked a lot about infrastructure as a service today. Can Densify help with optimizing my containers environment?
Great question. Yeah, we obviously, infrastructure just means to run something, and whether you run a cloud provider stack like EKS or AKS, or you run something like OpenShift in a public cloud, or another container stack of your choice, Densify can help you optimize container resources, because quite often you're just blocked by the choices of, say, requests that people specify, the reservations at workload level. We also have a play in ECS, which is the non-Kubernetes kind of version of containers. It's probably worthy of a whole another webcast to talk about container optimization and what Densify can do.
Yeah, and I did answer one question online where just go to densify.com. There's a whole whack of resources available for just the whole topic of containers and Kubernetes optimization. So last question, I know we're over time here, and it's a bit of a corollary to the whole containers, but you mentioned optimizing resource usage based on observed utilization. How does this work for auto-scaling groups in AWS?
Oh, another great question. So yeah, with auto-scaling groups, it's not as simple as just picking another instance type, because you have many workers working together for that service. So the optimal answer is what the right instance type is, but also what are your optimum kind of minimum, maximum, and desired standard kind of default number of instances for that scale group scale set. And Densify has advanced algorithms to provide that answer. Another topic probably for a whole different webcast.
Right. And so if you're interested in that, I mean, the impact on that is potentially significant. One customer I know, tens of thousands of dollars, hundreds of thousands a month spent in that specific area. And if you can optimize that, the impact, not just from savings, but also for performance and just making sure you're on the right instance type and with the right number of workers, very important. In any event, if you're interested in that, send us a note. Let us know if that's a topic you'd like to hear more on in a future webinar. And so we'll close it down for today. Mikhail, thanks so much for doing this, and look forward to May the 4th in 2 weeks on version 2 of this presentation. Everyone,
Thanks,
thanks so
Andy,
much.
and thanks everybody for your time.